Chapter 4 focuses on the concept of functions, which you should have some knowledge from Algebra 1 and Algebra 2. The definition of a function is it's a relation where for each x value there is no more than one y value. You might remember the test we had for this, and that would be the vertical line test. So if you remember back to algebra, if you can draw a vertical line and it passes through more than one point, then it's not a function. So for example, let's take a couple quick expressions. Let's take, for example, 1, f of x equals the square root of x. This graph looks like this. So you can see that any vertical line that I draw only passes through at most one point, therefore this is a function. If we take another example, such as x equals y squared, then when we graph this, if we solve for y, we get y equals the square root of x, but don't forget the plus or minus part, because they're radical. And therefore you actually have a graph of a sideways parabola. Notice this is not a function. So though it's related to number 1, this one's not a function because it has no bottom half. This is not a function. Two more other terms I would like you to realize leading into tomorrow's lesson is domain and range. Domain refers to all possible x values. The way I always remember it is x domain is a kind of alphabetical order, whereas range is for y. So it's alphabetical order, x, y, dr. So range is all possible y values. So if we go back to those problems up here, this domain would be all the possible x values. So when x is greater than or equal to 0. Its range would be all its y values, which would be y is greater than or equal to 0. On this problem, the domain is the same. X is greater than or equal to 0. But the range is now all real numbers, because this goes down to negative infinity and up to positive infinity. Tomorrow, we will focus on a special type of graph that you're not as accustomed to, called a piecewise graph. So the idea with them is you're going to have different parts of a graph. So let's do one example today, and we'll take this into tomorrow. Let's let f of x be equal to 2x when x is greater than 1, 3 when x equals 1, and negative x minus 1 when x is less than 1. What this basically says is we have one function that is defined by this function when this is true, defined like this when this is true, and defined by this when this is true. This means you're going to have three different parts of your graph. So the first thing I do when graphing these is I just find the values of 1. At 1, we know the function is equal to 3. So there's a closed dot there. On the top graph, when I plug in 1, I get 2. That's going to be an open dot because it's not equal to it at 1. Notice that graph is a line, and it's going to have a slope of 2. So it's going to go up 2 over 1. Up 2 over 1. And that would roughly be the graph of the right part, the right half of this graph. So this is the 2x part, this is the x equals 1 part. Now we have to graph the x is less than 1 part. So again, we plug in 1, we get negative 2. I notice the y-intercept is negative 1, so I'm just going to put a dot there, and there's my graph. So there is your first piecewise graph. We could talk about it. Is it a function? Yes, it passes the vertical line test. Passes there, even passes here. Notice that's the beauty of my piecewise function. Due to the way I defined it, you have 1 closed dot and 2 open dots, making it a function at that point. Also notice that its domain would be all real numbers, because all these x values are accounted for. All of these, at x equals 1, it is accounted for there, and then all of these. So its domain is all reals. Its range, on the other hand, would be every y value bigger than here. So all y values bigger than negative 2. So that kind of wraps up the intro to functions. Tomorrow we'll take this further with the piecewise graphs especially, and show you how we can apply it. Thank you.